Welcome back, everybody. So today we're going to talk about the 1905 Nobel Prize in Physics, which was won by the guy behind me. Before we get to that, click like, subscribe, or follow, or whatever channel you see me on. Be sure to follow along. That's how you'll find new announcements on the new stuff as I go through all the physics Nobel Prizes, followed by the chemistry Nobel Prizes. Probably go into economics after that. But so we're going to look at each one of these in turn. So today we have the 1905 Nobel Prize won by Philipp Eduard Anton von Lenard, German-Hungarian dude. Right there. He won the prize by himself. It was not shared amongst two or three people, which does happen more often than not, especially now. It was for his work in cathode rays, which cathode rays to you and I might seem like, well, gee, we've kind of that's obsolete stuff. Remember, this was 1905. So this was work he did either late 1800s, early 1900s. But what is a cathode ray? We all know a CRT, depending on the generation you are, you grew up with them. But it's a cylindrical anode electrode with a metal plate cathode with a small hole covered by thin aluminum foil. That's the goofy scientific explanation. We're going to get to what it actually does in a minute, okay? But that was what they awarded him the prize for, was for this stuff right here. Now, what that did, he wasn't just into cathode rays. He did a lot of other stuff. So for the cathode rays, he actually won the Nobel. He did a lot of work on the photoelectric effect, which is important because it is the emission of electrons from a material. So if you zap something with a material and get it excited, it does produce electrons. It's caused by electromagnetic radiation, ultraviolet light, all kinds of stuff, but a different topic. Grid control, which was the precursor to the triode, which is sometimes referred to as a thermoionic valve, which is important in electronics. Lenard window, which actually allows the passing of cathode rays from the vacuum tube into air, which is actually trickier than it sounds. Than it sounds. But what the heck is a cathode ray? So what are they? Well, it's just a beam of electrons emitted from a cathode inside a high vacuum tube. So if you produce one, it kind of looks like this little purpley streak here. You get this nice beam of electrons, and they kind of create some light. Now, what are they good for? Well, those led to the discovery and the proof of the existence of the electron. So without this discovery, the Nobel Prize that was awarded actually the next year could not have taken place because the cathode ray allowed the discovery and proof of the electron to be completed. People had kind of theorized about the electron before that, but nobody had ever kind of proven them out, which was the next award after this one we'll talk about on another video. But these are integral in the use of cathode ray tubes, which used to be in everybody's home for televisions before we had nice LEDs or plasma screens or whatever it is you use. We had CRTs, which were the big tube televisions. It took a couple of people to move around the basement or a living room or wherever because they were heavy as they got bigger. I mean, they were not light. It would give you a backache moving those things around. But he discovered something that led to the electron. The practical application of it was the television, originally in black and white and eventually in color. So the technology did take a while to develop, but the first one in the lab was this guy right here. Some might argue that we actually like those things. So that is the 1905 Nobel Prize in physics. And without it, we would not have really figured out what the electron was for a while. It would have taken a little bit longer. And without it, television wouldn't have occurred. So, at least not as early as it did. It would have had to wait for LED technology to come along and kind of be invented. And who knows what the world might be like if we didn't have TV? Maybe it'd be better, maybe worse. I don't know. But it would certainly be different. So, like I said, click like, subscribe, or follow. Hope you're enjoying the series on Nobel Prize winners. This guy is a pretty interesting guy, a Hungarian-German guy, worked in a whole bunch of areas. I think he would have probably been better known to people outside of physics had he not been working at a time that had, Marie Curie and, Einstein and just sort of some of the gargantuan physics minds that were running around at the time. He was a great physicist, a great experimental scientist, and in anybody's lab, he would be an absolute. Universities would fight over somebody like this today, but at the time, I think his presence was kind of overshadowed by some of the massive names in the field that were going on. So everybody, like I said, click like, subscribe, or follow. Have a great day, and we'll see you on the next video.